So today we're going to be learning how to do NCR problems. Now NCR problems are where you have to find the number of possible combinations of R items given n, the total number of items. So let's start with this problem. John has a choice of 4 different items and he can wear 2 on his wrist at the same time. So to make it easier, let's label our options. We'll do G for the gold watch, S for the silver, R for the rubber bracelet, and M for the metal. So to start off, we'll use a very logical and simple method of finding the combinations. We'll make 6 slots and we'll do first the gold watch and see all the combinations. So gold and silver, gold and rubber, and gold and metal. Now that we're done with gold, we'll do silver. So silver, rubber, and silver metal. We already did the gold and silver, so we won't be needing that. And the last combination which we haven't done is rubber and metal, which brings us to 6 total combinations. However, with problems with more options, that method becomes too difficult and time consuming. So for those types of examples, we use the NCR formula. For the formula, we see that there's a C, N, and a R. The C represents the total combinations possible. N represents the number of possible choices we have, and R represents the number of choices being made. However, there are also exclamation points we see in the formula. They represent things called factorials. Factorials are a way to represent the product of all the positive integers less than or equal to x. So as a formula, we see that x factorial is x times x minus 1, x minus 2, and so on until we reach 1. So for example, 4 factorial would be 24. Now this is because 4 factorial is just 4 times 3 times 2 times 1, which is 24. We can apply this to any integer, so 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5040. So with our knowledge of factorials, we can go back to the problem where we had 4 total options when we had to pick 2 to find the total combinations and plug them into the formula. C would be x, and n would be 4, as that is the total number of choices, and r would be 2, as we were allowed to wear 2 items at the same time. When we plug these values into our formula, we get 4 factorial divided by 2 factorial times 4 minus 2 factorial. When we expand this, we see that this is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Instead of multiplying this, we can cancel out the 2 times 1 at the top by the 2 times 1 at the bottom. Additionally, we can divide both the top and the bottom by 2, making 4 2 and 2 times 1 1. This results in us getting 2 times 3, which is 6, which is the same as what we found using the longer method. So now that we know the NCR formula, we can apply this into real-life world situations and the concept of probability. So in this question, we have to find the exact chances of a person winning a lottery where they have to choose 6 numbers correctly from the range of 1 to 49. Now knowing the NCR formula, we know that n is 49 as there are 49 numbers from 1 to 49, and r is 6 as we have to choose 6 numbers. Plugging this into our formula, we get 49 factorial over 6 factorial times 43 factorial. Expanding this, we see that parts of 49 factorial overlap with 43 factorial, which means we can cancel. This leaves us with 49 times 48 times 47 times 46 times 45 times 44, all over 6 factorial. After the canceling and doing the math, we get that there's a total of 13,983,816 total combinations. Now, as the order of the 6 numbers chosen does not matter, getting every single one of those 6 right is only one combination out of all the possible combinations we have. Now, since the winning combination of getting all 6 right is only one combination and we have 13,983,816 total combinations, the chance of winning this lottery would be 1 over 13,983,816.